Your homework on web work has been updated, so y'all can take a look at that. I know this topic that we're going over right now is mad easy, so if y'all want to take out your laptops and knock out the homework, be my guest. I completely understand. All right. So I'm kind of just picking up where we left off. I also forgot where we left off, so I'm just going to start right here. All right. This question says determine whether this point, 1 comma negative 2, is a solution to the equation. How do I do this?
X one, two, right?
Mm-hmm.
So
So what should I do with those numbers? Okay, I'll take that. Replace the letters with the numbers. All right. I was gonna say plug it in, but okay. That's just as good. So I have 3 times what number?
two,
1. Very good.
negative
Plus 4 times what? No. What's the y value? -2. Very good. All right. And what I want to know is, does that equal 11? I have no idea. All right. Remember that anytime they give you this pairing, right, in parentheses, that the first number is X and the second number is Y, right?
Yeah.
Remember that. All right, let's do the math on that, right? Y'all gotta help me out. I'm bad at math. What's 3 times 1? 3? Oh, y'all good. Y'all good. All right. It's a little bit harder now, right? What's 4 times -2? I'm impressed. All right. And what I want to know is, does that equal 11? All right. So what's 3 plus -8? It is -5, right? Now, we know for a fact that -5 does not equal 11. So what's the answer to the question? No, right? No, this, hold on, let me scroll down a little bit, is not a solution. All right. Questions on this? Just plug it in. That's all we have to do. All right. Feel like that was a little thick. All right. Anyway, keep clicking on the wrong thing. That's not too good. Anyways, do 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 do. All right. Same exact question. Tell me what to do.
plug it in.
Plug it in, right? So tell me what to write.
So 3,
Mm-hmm. Mm-hmm.
5,
Very good. What else?
plus terms,
Very good.
plus
Mm-hmm.
4,
Mm-hmm.
open terms,
Mm-hmm.
-1,
Very
close
good.
terms,
Very good. What else?
equal
Mm-hmm.
11.
Very good, right? So I want to see if that equals 11. Let's do it out, right? What's 3 times 5? All right, 15. Plus, what's 4 times -1? Very good, -4, right? And what I want to know is, does that equal 11? All right, so in fact, 11 does equal 11. So very simply, yes, this is a solution. All right, questions on this? Anybody? Good? All right. That's literally your whole homework for tonight. Is just that one topic right there. I have more to go over, but if y'all feel bored after that hearing about that, just go knock out your homework. All right. So the next thing that I want to go over, which you probably know how to do already, but just to make me feel good, right? So notice that in the previous two examples with the same equation, we found one solution of the equation, namely 5, -1. The one solution is made up of two numbers, the value for x and y for both for excuse me, the values for x and for y both need to be specified for a single solution. Okay, here goes another example. We want to determine if -½ is a solution to this inequality, right? So written another way, I want to know if x equals -½ is that a solution to this? So I have 5x plus 1 greater than or equal to -1, right? Tell me what to do here. Don't overthink it. It's the same thing. Exactly. Right? So this becomes 5 times -1/2 plus 1 greater than or equal to -1. All right, let's do the math on that, right? What's 5 times -½ Mm, kind of. Give me a fraction. Give me a fraction. Not -½ This is 5 times -1/2. Yeah, yeah, yeah. Yeah.
Can you do that in
Mhm.
your calculator?
Mhm.
The
Mhm.
equal, you can, right?
She can.
The,
Mhm. What's up, man? How are you? It's all good. It's all good, man. I feel you, man. Your traffic was crazy today, man. Yeah. A little bit of snow melts and everybody want to drive, you know? Yeah. So I'm trying to multiply this, right? So I got 5 times -½ What's the answer? Yeah. Huh? Say it again? I'm sorry. Yeah. Negative what? 2.5? No. Mhm. All right, so the 5, right, is a whole number. So we could write whole numbers over 1, right? So now 5/1 times -½ what's that? Hey, how do we multiply fractions? Straight across, right? So 5 times -1 is what? -5. And 1 times 2 is 2, exactly, right? So -5/2 plus 1 greater than or equal to -1. Let's finish that out, right? In order for me to add, I have to have the same denominator, so this becomes 1/1. What's the LCD there? The LCD, the least common denominator. What is it? 1? No. No. 2, right? So how do I make the 1 into a 2? Right, I'm going to multiply this by 2. But what I do to the bottom, I do to the top, right? So now I have -5 plus 2 over 2 greater than or equal to -1. Let's do the math on that. What's -5 plus 2? No. You owe me $5 and you give me 2. How much you owe me now? -3, right? So this is -3/2, right? Greater than or equal to -1. All right. Let's change this into a decimal to make this a little bit more clear, right? So I have 2 on the denominator, 3. 2 goes into 3 how many times? 1, right? And 2 times 1 is 2, right? So this becomes what? -1. And then the remainder is 1 over 2. And then this is greater than or equal to -1. Here's my question. Is -1.5 greater than or equal to -1?
How do you do that? That people,
Greater than.
you can call it,
Yeah.
like it.
That.
Okay.
Is it? I'm asking you.
What figure,
Is it? Huh?
I don't even know.
It's less than, right? Yeah, so this is a false statement. Exactly, right? So, long story short, going back to the original question, right? They ask us to determine if -1/2 is a solution to the inequality. It is not, right? Inequality, right? Very simple, just like that. Plug it in, see if the statement that you have is true or false, and that's it.
Can I do that in the calculated
No.
DI 36,
This one you can't. You could plug it in, and do the math in it and get the final answer, but you have to think through it at the end. Uh-huh.
so I'm not able to
Mhm.
doing no ways to do in the calculator.
You could plug in the -1/2 in for x in this part, and then do the 5 times -1/2 plus 1, and then come out with this part, the -1/2. You can do that part in the
Oh, but it's
calculator.
like a
Yeah.
lot different.
But you still have to write it down, -1/2, and then you have the greater than or equal to -1. You have to figure that out yourself. Yeah. If it's true or false,
Alright.
basically, right? Yeah. Any questions on this? Not too bad, right?
It is bad.
It's bad?
Yeah.
All right. I got you. Tell me when to stop. Okay. Oh, down like this way?
Yeah.
Okay. Okay. You're open. Good? No, you're fine. You want to stay after today? Mhm. All right. Okay. Slow down. And that's the bottom. I don't think on your homework you have too many questions like this. I think it's like 5 of them. something small. And they basically yes or no questions, you know. Does it work? Does it not work? Uh-huh.
So, like
Mhm.
in the test, we would have like this, right? We would put the whole problem, and then you'll ask,
Mhm.
is it less than, greater than, like that?
Right. Like the answer that I'm giving you, like does it work or not? Like yes or no. Yeah. So the inequality is false. So negative half is not a solution of the inequality 5x plus 1 is greater than or equal to -1. We're going to close this section with one of the most important definitions in this text, solving an algebraic statement. So to solve an algebraic equation or inequality means to find all solutions. All right. So every word in this definition is important. Here it comes. All right. All right. So one, solutions. So to solve an equation or inequality, we need to keep in mind what a typical solution looks like. Is it a number, as in the case for the statements with one variable? Is it an ordered pair, as in the case with the statements with two variables? All, right? To solve an equation or inequality, we need to know how many solutions the statement has. Does it have one solution? Does it have two solutions? Infinitely many solutions? Or does it have no solutions at all? Right? Last, find, right? Rather than guess solutions and then check whether in fact they are solutions or not, we would like to have a procedure that produces or finds the solution for us. All right, that makes it easy. All right. So here we go, solving linear equations in one variable. All right. So in this section, our goal will be to develop a method that will find all of the solutions for certain equations in one variable. All right. So let's start off with a very, very simple example. All right. So here we go. We want to solve x is equal to -2. All right. So what's the solution here? Don't overthink it. Yeah, what's the answer? Right. That's it. -2. It really is that simple. All right. So when you plug in -2, you see that -2 equals -2. That is a true statement. End of question. All right. But let's build off of that idea. All right. I know this week's homework is gonna be mad easy. Take advantage. All right. So if only it were that easy to find solutions to every equation. In fact, our first goal of producing a method to find all solutions to a given equation will be to convert it to an equivalent equation that has the same easy form as very, very easy example. We say that two equations are equivalent if they have exactly the same solutions. All right. In order to do this, let's first specify what made our very, very easy example so easy. One side of the equation is a number. All the operations involving numbers have been performed, right? The other side of the equation is an algebraic expression containing just one variable and no operations. One sometimes says x is by itself on one side of the equation, right? So long story short, we solved for x. All my numbers were on one side, all my variables were on the other, right? That's my goal. That's what I want. All right. A consequence of the second item is that the equation is linear. So a linear equation is an equation where the only operations performed on the variable are addition, subtraction, multiplication by a constant called a coefficient. So for example, the equation 3x plus 4y equals 11 is a linear equation with two variables. The equation x squared plus 5x plus 6 equals 0 is not linear because of the x squared term. It involves a variable raised to a power, right, different from 1. The remainder of this section will be devoted to the following sentence. Every linear equation, almost, in one variable, let's say x, is equivalent to an easy equation of the form x equals whatever. This is the solution to all of your questions. X equals blah, 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 right? That's your answer, right? And the blank will be a number. Easy enough, right? Questions on that? All right. Real quick. So there's an important consequence of this fact. Almost every linear equation in one variable has exactly one solution. All right. Next, we're going to talk about the rules of the game. Hey, what's good, man? All right. Let's make that a little bit bigger. So the rules of the game, right? So given any linear equation in one variable, x, no matter how complicated, we will develop a method to find an equivalent equation of the form x equals whatever. Then we'll be able to read off the solution to the easy equation. It will also be the solution of the maybe more complicated original equation also. The method will be based on the following two properties of equations. We have two properties, the addition principle, and we have something called the multiplication principle. All right? Don't overthink all the vocabulary. I'm just giving y'all a whole bunch of vocabulary, but y'all know how to do this already. All right? The addition principle, adding or subtracting the same quantity to both sides of the equation will produce an equivalent equation, right? The multiplication principle, multiplying or dividing the same non-zero quantity on both sides of the equation will produce an equivalent equation, all right? These properties can be summarized in the loose slogan, doing the same thing to both sides of the equation does not change the solution of the equation. So what you do to one side of the equation, you do to the other side of the equation, period. All right? As usual with loose slogans, though, we should be aware of the fine print. For example, multiplying both sides of an equation, which may be false by 0, will yield an equation 0 equals 0, which is always true. All right? Now let's talk about applying the rules. So we will use the properties in the previous section to attempt to start with a linear equation in one variable, say x, and obtain an equivalent equation of the form x equals whatever, right? Long story short, we're going to go through the motions of solving an equation. All right. I know it sounds like a whole lot of jargon, but you guys actually know how to do this already. And I'll show you. So since the equation, right, have the same solutions, this solution will be obvious by considering the simple equation. Recall that one of the special features of the easy equation x equals whatever is that the expression with the variable has no operations involved. Our guiding strategy for solving linear equations will be to identify the operations involved in the expression, involved in the expression involving the variable, and then to undo them one by one by using addition and multiplication principles. For example, let's solve this. I have x, right? Oh boy, hold on. Where did my mouse go? Here we go. Give me a second. All right. So I have x minus 41 is equal to 36. I want to solve for x. Tell me what to do. Don't overthink it. I want all my x's on one side, all my numbers on the other. All right. So what can I do to this to solve for it? Anybody. Exactly, right? I'm going to add 41 to the negative 41 to get rid of it. But what I do to one side of the equation, I have to do to the other side of the equation. I'm going to add 41 over here. So what's my answer? X equals, I don't know, what's that, 77? And that's it. Is there any questions on this? All right. This is how you solve for an equation. All right. Now, hypothetically speaking, right? Let's say that you're not even sure if you're right. You want to check if this answer is right. You know that your original equation is what? X minus 41 is equal to 36. All you have to do is plug in the value that you found, right? And then what you want to see is, does that equal the other side? And when you do the math on that, right? 7 minus 1 is 6. 7 minus 4 is, yeah, is 3, right? Turns out they're actually equal. That's how you check your work. This is what I mean by getting a question wrong in math class is optional, right? Because you can always check your answers. Right? Good stuff, good stuff, good stuff.
Check your answer, you always plug in that answer.
Mhm.
And you should get the answer.
If the left side,
Definition.
yeah, if the left side equals the right side, you're good to go.
That is easier.
That's easier?
Yeah,
All right.
you can put down.
I would argue that this is harder than what was on the first test. Yeah. You think this is easier or this was harder than what was on the test?
That one, so I mean, that exercise. I don't even know what one is.
Well, all the topics. All right, so since it's easy, show me what to do, or tell me what to do. I have 5x plus 18 is equal to 12. Don't overthink it. Don't overthink it. What should I do first? Say it again. 18. So how do I get rid of a positive 18?
Okay.
Right? So I'm going to subtract 18 from over here. But you know I got to be fair. When I do the one side of the equation, I got to do it to the other side of the equation, right? So I'm going to subtract 18 from over here. All right? So now I got 5x is equal to, what's 12 minus 18? Negative 6, okay? So now I want to get x by itself, right? How do I get rid of that 5 that's in front of the x? You got to divide by it, right? Because that's 5 times x. And how do you undo multiplication? You divide, you do division. But you know what I do to one side of the equation, I gotta do to the other side of the equation, right? So that's it. This is my answer. X is equal to negative 6 over 5. All right. Questions on this?
Easy.
It's easy? Good. Any questions on this?
So this is called self-rating.
Yeah. Mhm. It's possible. Yeah. Yeah, it's possible. But let's say that you don't believe it, right? Let's say that you don't believe it, right? You could always check it, right? So you got the 5x plus 18 is equal to 12, right? So if we plug in, right, the negative 6 over 5, right, plus 18, hold on, I forgot how to draw 8.
Can I ask you a favor?
Does this equal 12? Go ahead.
Alright, can you, any chance in the class, any, I don't know. And can you send us to the board to do an example? Like in
Okay.
person, we can learn, so, I guess like, so
Okay.
after you explain to see.
Okay.
We,
We could do that. We could do that.
yeah,
Tell me what to do after this now. I just plugged it in.
This another example.
I want to simplify
can-
this. I have 5 times -6 over 5. What happens? I'm sorry? Okay. So 5 over 1. All right. So then this becomes what? -30 over 5. Good. Plus 18. And I want to know, does that equal 12? So what's -30 divided by 5? All right. So -6 plus 18. I want to know, does that equal 12? I don't know. So what's -6 plus 18? So 12 does equal 12. So that's how you know that this is a true answer. And that's it.
Easy by the negative, there you.
By 5. Yeah. Mhm.
Over one times -6 over 5 is.
Because when you multiply fractions, you multiply straight across. All right. That's
I
fine.
got -6.
Same thing. Yeah.
Oh, so if it's not
Yeah.
-30, -6 is fine. Oh.
It's -30 over 5, which becomes -6. Yeah. Huh? Nah.
Just here.
That was like a week ago or 2 weeks ago.
Fresh. I don't multiply the top, you said the
Straight.
1 times -6 over 5.
Yeah, so the 5 is a whole number, so you put it over 1. Then you multiply numerator by numerator and denominator by denominator. Then you
So
divide.
that.
Yeah. All
Full
right.
multiplication.
Mm-hmm. All right. So that one was pretty good. So let's elaborate. Mhm. I know some of y'all probably bored right now. Go ahead, do your homework. This is all in the homework. Mhm. You good?
Right there.
Okay. All right, give me 1 second.
Okay.
Going to tutoring later if you guys want to come. Optional. All right. I think next week is supposed to be like midterms or whatever. So they're probably gonna have like some snacks and tutoring and all that if y'all interested. Free coffee and maybe some orange juice and stuff. If y'all interested. We took it already. Yeah. Because unfortunately I have to give in reports like today, so it's ruined everything. Huh? I'm in the process of it. I looked at every single question, but I didn't get a chance to like put the grades on and all of that stuff. Yeah. Okay.
Okay.
I believe this is on your formula sheet. All right. In case you guys doing your homework and can't remember the lesson, you can just look at your formula sheet and knock out the homework. Mhm. All right, so let's elaborate on this a little bit more. All right. So I made that a little too big. 1 second. All right, that's more perfect. So sometimes we will encounter statements with variables on both sides of the equation or the inequality. In this case, we will need to take an extra step to make sure that the equivalent equation has variables on only one side of the statement, like our easy equation. This can be done using the same addition principle that we have been using so far, but we need to make sure that we have been using behind the scenes more explicit, all right? In a linear equation in one variable, like terms are identified according to whether they involve the variable or not. In other words, terms involving the variable will be like terms, and terms not involving the variable will be called the like terms. The most important feature of like terms for now is that like terms can be added or combined, right? So when we add terms involving variables, we add the coefficients of the terms, but leave the variable part the same. So for example, 5x plus 2 plus 3x plus 9. The terms 5x and 3x are like terms, so we can add those together, right, to make 8x. Likewise, the 2 and the 9 are like terms, so we can add those together to make 11, right? So 5x plus 2 plus 3x plus 9 is equal to 8x plus 11. Any questions on this? All right, this is called combining like terms, which is a fancy way of saying adding, right? You add the ones that have the x together, you add the ones that are numbers by themselves, put them next to each other. They can't be combined. All right. So when we use the addition principle, we will make a habit of writing the like terms in the same column. For example, all right, I want to solve this. I have 3x minus 9 is equal to 8x plus 7. Remember, my goal is I want to get all my x's on one side, all my numbers on the other. All right, Danny, what should I do first? There's no wrong answer here. Well, first I want to get them all on the same, right? Okay. So, so what do you want me to do first? Okay, how do I move the 8 to the left? All right. So I'm going to subtract the 8x from over here. But what I do to one side of the equation, I have to do to the other side of the equation, right? Subtract the 8x from over here. Now, what is 3x minus 8x? Negative 5x, right? Minus 9 is equal to 7. So what do I do now? Add 9, right? So I'm going to add 9 over here to get rid of this negative 9. But what I do to one side of the equation, I have to do to the other side of the equation. So I'm going to add 9 over here. So now I have what? Negative 5x is equal to, what's 7 plus 9? Say it again? 16, right? And then now I want to get x by itself. So how do I get rid of that negative 5? Say it again? Divide by the negative 5, right? And what I do to one side of the equation, I have to do to the other side of the equation. Divide by negative 5. So this is my final answer. X equals negative 16 over 5. Questions on this?
Keep going it.
Mhm.
Get that.
Right.
You have to keep, doing, we go one side to the other, all the way.
Exactly. Exactly. That's it. Huh?
With the first step, the 8,
Uh-huh.
variable x.
Hmm.
If we had, if we did the negative 9 first, that'd be wrong.
No, that's fine. That's fine. It doesn't matter. Yeah. As long as what you do to one side, you do to the other, it's good.
I had
Yeah. If it was me, I would have moved to 3x first. Yeah. That's because I don't like negatives, you know. But that's just me. Yeah. It'd be the same answer. Yeah. Mhm. You do long division, right? So you have the denominator on the outside, numerator on the inside, just like this, and then just divide it out, all right? And then, but you keep going with it. You know, like how normally I'll stop and I'll write the whole number with the fraction next to it. You just keep going. Don't stop till you get to the last decimal. All right? That's how you do it. It's actually what the calculator does too. The bottom by the top. Yeah, so the bottom goes on the outside and the top goes on the inside for long division. Yeah. Mhm. Also in the calculator, like think of it as like top divide bottom. You know, if you were doing the regular long division, it would be the inside divides the outside. Mhm. But in this case, the fraction is fine. You don't need to simplify it down to a decimal and all of that. As long as you can solve for x, I'm happy. And as usual, you can always just plug it in to check. All right. I feel like you guys get that, so let's just move on. Mhm. Just want to talk about it first before we jump into it. So looking at the two methods above, the second method has the advantage that the coefficient, no problem. Just sign it. Oh, we'll check and sign. Yeah. So looking at the second method above, right, the has the advantage that the coefficient of the variable term is positive after using the addition principle to obtain an equation with the variable on one side only. That is because in the original equation, the variable term with the larger coefficient was on the right. From now on, we will follow the custom of writing our equivalent equation with the variable on the side where the original coefficient of the variable term was larger. The only thing that will make a linear equation in one variable more complicated than the examples we have seen above is if there are more operations on one or both of the sides of the equations. For example, we may have to perform multiplication using the distributive law if necessary, or we may have to combine like terms on one of the sides or both of the sides separately. So the following example illustrates this situation. Notice that before we begin to apply the addition or multiplication principles, doing the same thing to both sides, we will perform operations on each side separately. All right, so here we go. Tell me what to do. Just to recap, I got 4 times x minus 3 plus 2x equals 7, x minus 9. What should I do first? Hmm? Find a solution? Exactly, right? I should distribute this 4 onto both terms, right? So 4 times x, this is 4x, minus 4 times 3, which is 12, plus 2x equals 7x minus 9. What should I do now? Before that, before that. I'm saying it? Combine like terms, right? So what are the like terms I'm combining? Not the negative 12. Say it again. And 4x and the 2x, right? I want to combine the like terms. So what's 4x plus 2x? Exactly, right? So this is 6x minus 12 is equal to 7x minus 9. All right, what should I do next?
Oh, sorry, what they did, so seven
Uh-huh.
X, I can pay attention, fix it.
So the 6x is coming from the 4x and the 2x. You're combining the like terms. All right. So you have 4x and 2x, which are like terms. You add them together. All right. Mhm. So what should I do? Oh, you want me to subtract 6x from over here? Okay. And what I do to one side, I gotta do to the other, right? So now I have negative 12 is equal to, what's 7 minus 6 again? 1, right? So this is x minus 9. And what should I do after this? Sorry? Not negative 12. With the 9, right? So I'm going to add 9 over here. But what I do to one side of the equation, I have to do to the other side of the equation. So what is negative 12 plus 9?
-3.
Negative 3. So this is negative 3 equals x, which is the same thing as saying x equals negative 3. And that's my answer. All right? Go ahead. Which
So
part?
you already told me, but I don't understand. They say
So
-9, no, it's
I have this term right here. I mean, I have these three terms right here, right?
4x.
4x minus 12 plus 2x, right? I have to combine the like terms, right? So I combine the 4x and the 2x. When I say combine, I mean add. So 4 plus 2 is 6x. Then after that, move all the x's to one side, all the numbers to the other, and that's it. All right. Questions on this? Good. All right, let's summarize what we just went over because that was a lot. All right. So we're going to summarize solving linear equations in one variable for x, right? Step 1, simplify each side of the equation separately. Perform any multiplication using the distributive property if necessary, all right? After that, combine like terms, right? Variables with variables, numbers with numbers, all right? Step 2, use the addition property to form an equivalent equation with all the variables on one side of the equation, right? Step 3, use the addition property to form an equivalent equation with all the constant terms on the other side of the equation, right? And then use the multiplication property to form the equivalent equation of the form x equals blah, 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 right? And that's it. So some unusual cases, excuse me, linear equations in one variable that do not have exactly one solution. So we mentioned above that almost every linear equation in one variable x, right, there's an equivalent equation of the form x equals whatever. And so almost every linear equation has exactly one solution. In this section, we'll illustrate what can go wrong. So here we go. Got y'all with another example. This is 2 times x minus 3 plus 4 is equal to 2x minus 2. Tell me what to do. Okay. So I'm going to distribute, right, the 2 onto both terms. So now I have 2x minus, what's 2 times 3? Very good. 6 plus 4 is equal to 2x minus 2. What should I do after this?
Combine like terms.
Right? Combine like terms. So what are the like terms here? Not the 2x.
No.
Mhm.
Oh.
What are the like terms here? Say it again. not the 4. I want to combine like terms, right? So what is it? The -6 and the 4, right? So what's -6 plus 4? -2, right? So now I have 2x minus 2 is equal to 2x minus 2. What should I do next? Say it again. Add the 2's on both sides. All right. So I'm going to add 2 over here. What I do to one side, I got to do to the other. All right. So now what do I got? I got 2x is equal to 2x. What do I do after that? Divide by 2, right? So I want to get x by itself. What I do to one side, I got to do to the other, right? So now what do I got? I got x is equal to x. What does this mean? Not 1. So what's the answer here? I like the way you think. Similar. So what this means, right? Anytime you see this when you're doing your homework or whatever, there are infinitely many solutions, right? It is linear, but there's many solutions to this equation. Any value of x that I want to plug in will work, right? In the previous examples, we only had one answer. This one has infinitely many answers. So infinite solutions. Pretty cool, right? Anytime you have x equals x, or the whole real numbers, every real number works. Everything that you could think of, right? Infinite solutions. All right. What about this? I know this is going kind of fast. Remember, it is being recorded, so you guys can rewatch it again. All right. Tell me what to do here. I have x plus open parentheses 2x minus 9, close parentheses equals 3 times x plus 1. Tell me what to do. X times 2?
I'm confused.
So, so this one is addition, not multiplication, right? Addition, right? So what should I do here? Or tell me what to write, whatever. I can. Okay. I can distribute this to both sides. That's true. So this becomes 3 times x, which is 3x, plus 1 times 3, which is 3. What's next? Say it again. Divided by 1? Okay. If you want to do that. Well, add it. That's what I want you to say, right? So 3x, my man. That's what I'm talking about, right? So this becomes 3x minus 9, right? I'm combining like terms, right? So I have 3x minus 9 is equal to 3x plus 3, right? And what should I do next? Which one? The 9? Oh, you want me to subtract the 3x? Is that what you're saying? It doesn't matter. Which one you want to do? You in charge. The 3x? All right. Right. 1x plus 2x is 3x. Yeah. Would All right. I could plus 9 if you want to do that. All right. So what I do to one side, I gotta do to the other. So now I got what? Hold on. I got 3x is equal to 3x plus what's this, 12? What should I do next?
Okay,
Huh?
you got,
Not divide.
here.
Right, I want to move the 3x to the other side, right? How do I do that? Not divide.
I'm confused because every extent was
Yeah.
different.
It's the same thing I'm doing, adding and multiplying. Yeah.
Oh, but,
Say it again?
well,
Not, not divide, subtract, right? I'm going to subtract the 3x from over here. But what I do to one side, I got to do to the other, right? 3x minus 3x is, that's what I'm talking about. So now I have 0 is equal to 12. Is that true?
there was
Is that true?
no.
Right? So this is a false statement, right? So what does this mean? There are no solutions to this equation. Huh? In the homework, yeah, you got those. Yeah. So we have three scenarios, right? When x is equal to a number, there's one solution, we're done. Boom, right? We have another solution where we have the same thing is equal to the same thing, like x is equal to x. That's infinitely many solutions, right? When you have a false statement like this, 0 equals 12, right? Then you know that this is not true. There are no solutions to this equation. All right? Questions on this? All right, these are three types of answers that you're gonna get on your homework in a nutshell. No, it'll be 0 because 3x minus 3x is 0. Yeah. Mhm. Also, if you're doing the homework and you have something like negative x equals like 12, for example, just making it up, right? You want to divide by that negative because think of that negative as like -1, and you want all the numbers on one side and all the variables on the other. So make the x positive always. Mhm. So that's pretty good. Let me introduce to you guys a new vocabulary word, something that you will appreciate actually. Ties in with your major. All right. So again, eliminating the variable from one side, right, had the effect of eliminating a variable entirely from the equation. But this time, the original equation is equivalent to an equation which is false. No matter the value of x, the equation has no solution. So an equation which has no solution is called a contradiction. All right? You can use that in law. All right? All right. Let's just recap real quick. Mhm. So we can summarize the results about solutions to linear equations in the following general fact, which is not almost always true, but is always true. For every linear equation in one variable, one and only one of the following statements must hold true, right? The equation has exactly one solution. That means x is equal to whatever number, right? It is an identity and every number is a solution. That's the x equals x, right? Or it is a contradiction and it has no solution. So you have something false like 0 equals 12, right? So this has what might be a startling conclusion. If a linear equation in one variable has two different solutions, then it must have infinitely many, all right? So next, another use of the multiplication principle, we're going to talk about equations involving fractions, right? Listen, a fraction is just a number, all right? Don't overthink it. It's just a number, all right? In this section, we'll illustrate how to use the multiplication principle in order to clean up equations involving fractions. While this is an extra step compared to the four-step process for solving linear equations in two variables above, it does reduce the need to perform arithmetic with fractions that requires extra care and attention to detail. The extra step that we're going to introduce when we attempt to solve an equation involving fraction is to multiply both sides of the equation by a common denominator of all fractions appearing in the equation. By the distributive property, this amounts to multiplying every term on both sides of the equation by the common denominator. Since, by definition, every denominator will be a factor of the common denominator, the multiplication will have the effect of ensuring that every term will only involve integers, right? So basically, the strategy here is to get rid of the denominators, right? And then once you get rid of the denominators, you're back to the original question that you had at hand. For example, let's look at this. So I want to solve 2x over 3 plus 1 over 4 is equal to 4, right? So we got 2x over 3 plus 1 over 4 is equal to 4, right? Just keep it simple, right? What's the LCD here? Not 3, 12, right? So all you have to do
Multiply.
is multiply both sides by 12, and you call it a day, and you're not even dealing with fractions no more, right? So let's check this out, right? When I distribute the 12 onto both terms, it's gonna happen over here too, right? So 12 times 2 over 3 is what? It's what is the 12? Starts with an L. It's
So
the
that we multiply the.
LCD, right? Between the 3 and the 4. Right.
Okay.
Yeah. So now, when I multiply 12 times 2 over 3, what do I get?
12.
You could put it over to 1. Very good. 24x over 3, right? And then when you divide that, 24 divided by 3 is what's that? 8, right? So this is just 8x plus. Now I have 12 over 1 times 1 over 4. What's that? It's going to be like 12 over 4, which is 3, right? Very good. Right? And then 4 times 12 is what? 48. Where'd I lose you? Huh? Everywhere? Uh-huh.
You did.
Yeah, for you, just do 12 times 2 over 3 and you'll get 8. Mhm. 3 times 4. That works too. Yeah, you could do that. So to find LCD, right? Take the larger number. Let's say like the 4, right? 3 doesn't go into 4 evenly, right? So double the 4 now. So 4 times 2 is 8. 3 doesn't go into 8 evenly, right? So then 4 times 3, what's that? 12. The 3 goes into the 12, so that would be the LCD. That's the easier way to do it. Or if you don't want to go through that nonsense, you could just multiply them together. And that way you find a common denominator and you multiply that on both sides. Right? Huh? Oh no, I'm not done. No. That was just how to get rid of the denominator. So now we back to what we were doing before. So what's my next step? Subtract what? Exactly, right?
Where got 8x?
12 times 2 over 3.
Okay. So.
Yeah. So now I have 8x is equal to 45, right? What do I do after that? Say it again. 8x equals 45, so I want to divide by exactly, right? And that's it.
3 and 3.
So you subtract the 3 from both sides, and that's how you change the 48 into 45. So now you got 45 over 8. Yeah, you could just keep it like that. All right. Questions on this?
Yeah.
Oh, the 3? So that's 12 over 1 times 1 over 4. So 12 times 1, 12, 1 times 4, 4, and 12 divided by 4. Yeah. Mhm. This is a trick that I'm showing you guys in case you don't want to work with the fractions, right? But let's say you don't care about fractions, like I don't care about fractions, right? For me, I would have just subtracted the 1 over 4 on both sides and then divided by the 2 over 3 and called it a day. And I'd have got the same answer. You know? So because I don't care about fractions, I work with fractions, you know. But if y'all want to get rid of the fractions, you multiply it by the LCD on both sides. Yeah. Try it when you guys go home. All right. It would give you the same answer if you just worked with the fraction.
When you got that 12, right?
Mhm.
You put the 1 over, that's because you always put the 1.
Yeah. Yeah, yeah. Because it's a whole number. It's a whole number, yeah. Yeah. Ooh, you confident, man. You charging it in the hallway? Yeah. All right.
You
Okay.
multiply the 12, the 1, with the 12 and the 2. That's
Yeah. 12 times 2, 24. 1 times 3, 3. 24 divided by 3, that's the 8. You can do it in a calculator, just 24 divided by 3.
12 times 1
Or 12 times 2, straight across.
and 12 times 2.
And so 12 times 2 on top, 1 times 3 on the bottom. And then you have 24 divided by 3, which is 8. Like that.
I'm so confused.
Wait,
What you confused
Now,
about?
the 12, you do the first step. 12 times 2 over 3 is 8x, right?
Correct.
Huh?
Correct.
Correct. And then you the 12 times 1, right?
1 over 4
1 over 4 is 3.
is 3.
Correct. And then you subtract it, or how can I?
And then on the other side, I did 4 times 12, which is 48. Right?
12 times 4.
Right, which is 48.
Okay, and
And
then
then
minus 3 from where?
from both sides.
Okay.
Yeah. That's how I got the 45.
Let's see.
Yeah.
Then your 12 times.
Yeah. This is just an option for you guys. 12 times 2 over 3. This is just an option for you guys. You guys don't have to do it if y'all don't want to. It's only if you don't like fractions and you don't want to work with them. Let's look at another example.
Yeah.
All right. So in the previous example, we wrote out all the steps all the steps involved in applying the distributive law after multiplying both sides by a common denominator. In the future, we will omit the step showing the multiplication on both sides and apply the distributive law directly by multiplying every term on both sides of the equation by a common denominator. So let's look at this one. All right. So I have x minus 2 over 3 plus 1 over 2 is equal to x over 6. What's the LCD here? Don't overthink it. 3 times 2, which is
3 times 2. Oh,
which is
6,
exactly right. So I'm going to multiply both sides by 6,
but that's
right? So
6 times
now,
x negative 2 over 3.
mm-hmm,
And
right? And then over here, we're going to have 6 over 1 times 1 over 2 is equal to, what's this?
where you got
1 over 6 times 6 over 1. It's, uh-huh.
where you got 6 times x and then is 6 and then 1 from here, 6 over 1.
Mm-hmm.
And then 1, 2, 1, 2. Okay, then you,
Mhm.
okay, got it. And then 1 over 6,
So what is 6 divided by 3? What's that?
flip, you flip there.
Mm-hmm.
Oh,
I just put it on the numerator. I just put it on the numerator. Because remember, this is 6 over 1. So,
okay, okay.
yeah.
You got
Mhm. What is 6 divided by 3? What's that?
2.
All right, so this becomes 2 times x minus 2 plus, what's 6 over 1 times 1 over 2? Yeah, so what does that become? 3? 1 over 6 times 6 over 1 is 6 over 6, which is, what's 6 divided by 6? 1, right? So boom. It's like these cancel out. All right. Now it's simple. Distribute, combine like terms, blah, 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 solve for x, right? So what should I do next? Very good, right? Distribute the 2 over here. So I have 2x minus 4 plus 3 is equal to x, right? What should I do after that? Starts with a C. Okay, what's up? Where'd I lose you?
6. Subtract. No.
Oh, just divide it. 6 divided by 3 to get the 2 on the outside.
Down.
I mean, it kind of does. It could be, but I'd have to divide each one by 3. So I still come back out to the 2x minus 4. So just divide this. All right. So 6 divided by 3, that's the 2. All right. So what should I do after this? Starts with a C. I'm on the last step. Combine like terms, right? So what are the like terms here?
Okay.
Not the 2x, the 3 and the 4, right? So what is negative 4 plus 3? All right. So this is 2x minus 1 equals x. What should I do next? Hmm? Very good, right? I'm going to subtract 2x from both sides. The one side do to the other. So now I have negative 1 is equal to, what's this?
1.
Negative 1x, right? But remember, I got to get x by itself. So how do I get rid of that negative 1? All right, I have a negative 1 in front of the x. How do I get rid of it? I could do that, right? So you're suggesting I multiply by negative 1. And then what you do to one side, you do to the other,
Or
right?
negative 1x is number.
No, it has to be x positive always, right? So now this becomes negative 1 times negative 1 is positive 1, which equals x. So final answer, x equals 1. And that's it. Questions on this? As usual, if you don't believe it, just plug it back in. Make sure that the left side equals the right side, and that's it. All right. Not too bad. Not too bad. Uh-huh. Mhm.
What we have for parentheses, negative one on the sides, but it was negative one equals negative one x, right? We didn't want to multiply.
I agree. I agree with you. It should have been division, right? Yeah. But technically speaking, the multiplication does the same job too.
Yeah.
You know? Yeah. But I feel you on that though. Like it could be like this too. Right? But it's still the same answer. Yeah. Yeah, yeah. The reason why I get away with that is because it was one. Had it been something else, I can't do that. Right? All right, last thing I want to talk about. Y'all don't have this on your homework, but this is going to come in real handy later on in the class. Real, real handy. All right. So I want to talk about word problems in math. All right. So in this section, we will apply the techniques of solving linear equations in one variable to some mathematical word problems. In doing so, we will pay special attention to the problems of translating between English and algebra. The technique outlined here emphasizes the translation aspect by using words like dictionary, right, which are essential ingredients in translating from one language to another. For each word problem, we will follow the following four-step procedure. So this is how you solve a word problem in math, all right? Step one, create a dictionary for the problem. The dictionary consists of a list of all unknown quantities, each expressed both in English and as an algebraic expression. Step two, write an algebraic equation that represents the problem. This involves using the dictionary from the previous step. Step three, you want to solve the equation. So this is just using the technique we have been discussing in this chapter. It is the one step where the technique of algebra are used, right? Step four, answer the question. At this point, the solution of the equation from the previous step, along with the dictionary, should allow us to answer the question asked in the original problem. That's simple. All right. That's how you do a word problem. All right, but let's take a look at an example real quick. So check this out. So let's see how this four-step technique works in a few examples. Here's an example. The sum of three consecutive integers is negative 237. Find the integers, right? What does consecutive mean? Huh? Say it again. In a system, in a row. I like that, right? In order. I like that as well, right? I was thinking one after the other, right? So for example, right? 12, 13, 14. Those are consecutive, right? They come one after the other, right? So let's try and solve this. The sum of three consecutive integers, right? So what are those integers? I'm going to write them as variables, right? So we have x, right? Plus what's the next number after x? I like the way you think, right? That's good. That's good. That's good. X, you got it. X plus one, right? That's the next integer right after x. And what would be the next integer after that? Exactly, x plus two, right? So the sum, when I add these three integers together, I get negative 237. And just like that, the problem is done, right? Combine like terms. X plus x is 3x, right? And then 1 plus 2 is This 1 plus 2, 3, right? So that's going to be equal to negative 237. What should I do after that? Say it again. Remove the 3, right? So I'm going to subtract 3 from over here. What I do to one side, I got to do to the other, right? So now what do I have? I have 3x
You say
is
X
equal to
times 2 is 3.
x plus x plus x is 3x, right? So like 1x plus 1x plus 1x, right?
It's sum, does that
Mhm.
mean? Okay.
Right. Sum means add, right? Also, if you guys use like Excel, the function to add a whole bunch of cells together is sum, the sum function, right? It's also the same thing as the sigma, right? That we learned earlier. I really did a bad job of drawing that just now. Negative 237 minus 3, this is like negative 240. And then I want to solve for x, so I'm going to divide by 3. What I do to one side, you know I got to do to the other. All right, so x equals what? 80? Negative 80, right? So bam. So if x is negative 80, right? What's the next number? Because remember, it's 3 consecutive numbers, right? We have x plus 1, and then we have x plus 2. So we said x is 80. So what's the next number? So it's going to be, excuse me, it's going to be negative 80 plus 1, which is negative 79, right? What's the next number? This is going to be negative 80 plus 2, which is negative 78. So what are our three numbers? It's negative 78, negative 79, and negative 80. Those are our three consecutive numbers that when you add them together will give you negative 237. Questions on this? This is fun, right? Maybe like one question.
Can I
Yeah.
go? I have a
Yeah, go ahead. Yeah, maybe like one question might be on the test, but nothing crazy. All right, real quick, just for fun, let me just answer one last question. I'm just gonna do this real quick and then we can go. Don't forget to sign the sheet before y'all leave, right? I'm just gonna do one last quick question, one last quick question. One last example, right?
Yes, sir.
Mhm.
How long you about attendance?
Huh?
How long you about attendance?
Good. Good.
No, you having on attendance?
Yeah. All right. So the length of a rectangle is 3 more than twice the width, right? The question is find the dimensions of the rectangle if the perimeter is 75 inches, right? So we have to use the fact that the perimeter is given by perimeter is equal to 2L plus 2W, all right? So I have the perimeter is equal to 2L plus 2W, right? And I know that the length of the rectangle, right? Length is the L, by the way, right? Is 3 more than twice the width. So if I double the width and I add 3, that's equal to the length, right? And I know that the perimeter is also equal to 75 inches, right? So all I have to do is just plug in the formula and we're done. This becomes 2 times the length, which is what? 2W plus 3 plus 2W, right? After that, we just got to solve for W, right? Distribute the 2. This becomes 75 is equal to 4W plus 6 plus 2W. Combine like terms, this becomes 75 is equal to 6W plus 6. I'm going to subtract 6 from over here. What I do to one side, you know I got to do to the other. RC man. All right. So this becomes what? 69 is equal to 6W. Right? And after that, all you got to do is just divide by 6. Just like that. Right? And then what do we get? What is this? Like 23, I see, man, like 23 over 3, something like that. No, 23 over 2. I think that sounds a little bit better. Yeah, 23 over 2 is equal to W. Right? So that's the width of the rectangle. To get the length of the rectangle, see, man, just plug it in, right? So length is equal to 2W plus 3. Let's verify that. Plug in the width that you just found. So this becomes 2 times the 23 over 2 plus 3. These 2's will cancel, leaving just 23 plus 3, which is 26. So my length is equal to 26. And my width is 23 over 2. That's it. All right. That was the last question. You want to see the word problem? We got that. Okay. All right. That's it, you guys. It's being recorded. You guys can rewatch it while you're doing your homework. All right. It was crazy, right?